All right, in this video, we are going to talk about absolute maximum values and absolute minimum values. So the absolute maximum value of a function is the y value of the highest point on the graph. All right, if such a point exists. There's plenty of graphs that don't have a highest point, right? And so in that case, we just say that the function has no absolute maximum value. And pretty much the same in the other direction for the absolute minimum value. It's the y value of the lowest point on the graph if such a point exists. Okay, and if no such point exists, we say that the function has no absolute minimum value. All right, so all of the sinusoidal functions have absolute max and min values, right? There's always going to be a highest point on the graph where those peaks are, and always going to be a lowest point on the graph where the where those valleys are. And in fact, right, there are going to be infinitely many points, right, that have the same that are where you have an absolute maximum value, and that's okay. You'll notice though that y coordinate is the same for all of those for these sinusoidal functions. Okay, and same thing for the absolute minimum value. So there's infinitely many points at which that absolute minimum value will be a y value of a point on the graph. All right, so those points basically where they are controlled by this value of a, the amplitude, and then the vertical shift, right? Because those are the things that are going to control how far up and down the graph goes, right? How far it's stretched vertically. And looking back, you can see it's pretty easy to figure out where or what those absolute maximum values are and absolute minimum values are by just looking at the value for d, the vertical shift, and then the absolute value of a, which remember is the amplitude of the sinusoidal function. So the absolute maximum value is just going to be d plus the absolute value of a, or the vertical shift plus the amplitude, and the absolute minimum value is going to be the vertical shift minus the amplitude. Okay, and that's it. All right. So let's take a look at some examples here. Notice if you have a nice accurate graph, then it's pretty easy to tell, right? You can see it's 1 and -7 here, right? So the absolute maximum value is going to be 1. The absolute minimum value is going to be -7. But let's just use the formula to do that. Let's say we didn't have the graph and didn't have the means to graph it out. How would we know? Well, what we would do, right, is for the absolute maximum value, we would take the vertical shift, which is -3, and then we would add the absolute value of -4, which is +4, and that's the amplitude. So I get -3 plus 4, which is equal to +1, right? And you can see, sure enough, that's where the absolute maximum value is +1 on this. And then for the absolute minimum value, it's the vertical shift, -3, or midline, however you want to call that, minus the amplitude. That's going to be -3 minus 4, which comes out to be -7. And again, you can see that works out. All right, let's look at the next example. All right, in this case, the amplitude is 3 rather, right? The absolute value of the number out in front here, the number that's being multiplied times the trig, or the sine or cosine, and the vertical shift is 2, right? So the absolute max value is going to be 2 plus 3, which is 5. The vertical shift plus the amplitude. The absolute minimum value is going to be the vertical shift minus the amplitude, which is -1. So 5 is here, -1 here. All right, and that is it.